Hello again. In this session, we will discuss motion under gravity in two dimensions. Now, such a motion is often called projectile motion. So, projectile motion is motion of a particle under the influence of gravity when it moves in two dimensions. Right. So, let's now see how we will analyze such a motion. So, let's say a particle is thrown at an angle with horizontal. Let this angle be theta. Then, as you can guess, this particle would first rise up to a certain height and then fall back to the ground. So, the motion of the particle would be something like this. It starts from this point, let's call it A, and falls back at the point B. Right. So, such a motion is called a projectile motion. Now, in this case, we are given the initial speed with which it was thrown and the angle with the horizontal at which this body was thrown. We are interested in finding, first of all, the time after which it falls back to the ground. And this time is called the time of flight. So, we wish to find the time of flight, then we wish to find the range of this projectile. The range of a projectile is defined as the distance between the point of launch and the point where it finally fell back. So, the distance between AB is defined as the range of this projectile. So, this is what we wish to find. The range of a projectile thrown with a speed u and at an angle theta with the horizontal. And finally, we are interested in finding the highest distance from the ground, the maximum height it attains during this motion. As you can see from this diagram, somewhere in the middle, this would be the highest point during its trajectory. So we have labeled it H max as it is the maximum height from the ground it attained during its motion. So these are the three things that we wish to find. Right. Now, the only difference from our previous problems is that in this case the particle is moving in two dimensions. That is, if we take the horizontal as x-axis and the vertical as y-axis, then the particle moves along x as well as y-axis. Right. So if you recall, a few sessions before we had discussed that two-dimensional motion is nothing but two one-dimensional motions occurring simultaneously. And whenever we have to analyze such a motion, we should break the things down into two components and then analyze these two one-dimensional motions separately. So once again, we will do the same thing. So to do that, first of all, let's try to find the initial velocity in both directions. For now, we know that the initial velocity points at an angle theta with the horizontal. Now the horizontal is our x-axis and the vertical is y-axis. So, if you recall our discussion from vectors, we had seen that a single vector which points somewhere in the middle can be broken down into two components, one purely along x, the other purely along y. And if you remember the expressions, then this component along x we found had a magnitude u cos theta, and the one along the vertical had the magnitude u sin theta. If you ever forget this, it's not very hard to calculate. All you have to do is complete a right angle triangle and then use simple elementary trigonometry to find the magnitude of the horizontal and the vertical components, because in this right angle triangle u is the hypotenuse. So this side becomes u cos theta and this one becomes u sin theta. Right. So let's start writing the variables separately. Here we will list down the variables of x, and here we will list down the variables of y. So far we have found the initial speed along x and y, or rather we should say initial velocity along x and y. So initial velocity along x is u cos theta. Also, we are taking this direction as positive for the x-axis, and for the y-axis we are taking upwards as positive. So we can now put everything with sign. The initial velocity you see is in the direction we have taken positive, and hence along x u cos theta is positive. Now let's look at y. U sin theta points upwards, and along y we have taken upwards as positive. Hence the initial velocity is u sin theta. Let's also represent initial velocity for x as ux. So value of ux is u cos theta, and uy is the initial velocity along y, and that becomes u sin theta. Right. What else do we know? We know that whenever a particle moves freely in the air, it only has one acceleration, which is downwards, and it is called the acceleration due to gravity. So if it has a downward acceleration, we know it has an acceleration along y. Also, we know that this acceleration is downwards. So if it is downwards, we can say that acceleration along y is minus g. This is minus g because the acceleration, which is the acceleration due to gravity, is pointing downwards. Right. What can you say about the acceleration along x? Well, we will later study that force has a relation with acceleration. In absence of force, there is no acceleration. And you can also intuitively tell that since this body, while in the air, is only pulled downwards, it will not accelerate in the horizontal direction. Right? Also, we will later be able to argue that since there is no horizontal force, the horizontal acceleration is 0, which means the acceleration along x is 0. So we can say that ax is 0. So this is all the given information. Right. So let's first understand the entire situation again. We are given a particle which has been thrown at an angle with the horizontal. We see that this particle through its flight is only pulled downwards by gravity, and there is no other force acting. We are interested in finding its time of flight, its range, and the maximum height it attains. And to do that, since this motion is two-dimensional, we are going to break everything down into x and y, and then analyze the entire motion as two one-dimensional motions. Right. So we have done that, and now we can think of these two as two separate problems, two completely independent problems. Right. Because x and y are completely independent of each other. Right. So let's come to the first part, which is the time of flight. So what happens at the time of flight? Time of flight is the point where this particle falls back to the ground. Now once again, the thing to do here is to identify this event, that is falling back to the ground, in an equation. So how do we identify that? How does this event of falling back relate with any of our known variables? Think about it. This falling back essentially means that it has come back to the same height as it was before. So if we talk about y, if we strictly watch the motion along y, we could say that along y it went to a certain height and then came back. Right? What does this tell you? This tells us that displacement along y is 0. Right? So when it was launched and when it falls back, during this time, it does have some displacement along x, which is actually the range of this projectile. But along y, it has witnessed 0 displacement. Right? So at the time of flight, at the time when it reaches back, the displacement along y becomes 0. So let's use this fact for the first part for the y axis, right? So let's use the second equation, of course, because we have initial speed, acceleration and displacement. So we know for the first part, we know Sy, we already know Uy, Ay and T is to be found. So looking at this set of variables, you can obviously conclude that we should use the second equation of motion, right? So doing so, we know that Sy will be equal to Uyt plus half Ay T square. Now substituting values, you see that Sy is 0, Uy is U sine theta, T is left as such, minus the acceleration along y is minus g, and hence this minus, so this becomes minus gt square by 2. You can rearrange this term, I'm sure you can do it by yourself. You see that t, one of the t will go to 0 left hand side and it will still be 0. So you get that t is equal to 2u sine theta by g. So this is the time after which the particle will fall back to the ground. To find this, we use the very same fact that it has fallen back to the ground, which means its displacement along y has become 0, right? So now let's think about the second part, which is the range of this projectile. Once we have the time, it is very easy to find, because along x there is no acceleration at all. So if there is no acceleration, looking at the second equation, which is Sx is equal to uxt plus axt square by 2, you see that the second term simply goes to 0. If you substitute the known values, since we already know ux and t, you see that Sx, which is the range, is equal to ux is u cos theta into the time, which is 2u sine theta by g. You see that the range is equal to 2u square sine theta cos theta by g. Now this expression can be further simplified, but at our level we can leave it as such. So this expression gives you the range of a projectile, right? The more critical thing here is to see how we are analyzing this problem. At our level, we need not remember these expressions, but you must understand how we are handling a two-dimensional problem, right? So finally, we have H max. How do we identify this event of attaining the maximum height? Think about it. What did we do in the case of one dimension? We said that the highest point will be the one where the ball will stop rising. It will stop moving in that direction. So we had said that at that point the ball will momentarily stop. But in this point, can that happen? Had the ball stopped at this point, it would have fallen vertically down, right? Because if it stops, it comes down with gravity, right? But still, the fact remains that it stopped rising in the y direction, right? So, in this case, in case of two dimensions, when the highest point comes, at that point, only the speed along y becomes 0. So we can say that at the highest point, the y component of its speed becomes 0. The y component of its velocity, to be more precise, becomes 0. At the highest point, the velocity is strictly horizontal, right? So let's use this fact. We know that Vy is 0. We know that Uy is equal to u sine theta. The acceleration along y we already know is minus g, and we wish to find the displacement along y, because the H max here is nothing but the displacement along y up till this point. right? So Sy is to be found. So once again, look at the set of parameters we have or are to be found. We see that the third equation will help us get our answer. So using the third equation, we can write that Vy square minus Uy square is equal to 2 into Ay into Sy. Making substitutions, you see that 0 minus U square sine square theta is equal to 2 into minus G into Sy. So the minus signs will cancel and you finally get that the H max for this projectile is equal to U square sine square theta by 2G. Right, so this is the expression for the highest point, for the maximum height attained whenever a projectile is launched at an angle theta with the horizontal and with the initial speed u. Right, so you don't need to remember any of this. If you want to, you can, but at our level we really don't need this. But what you must remember is how we are analyzing the situation. Right, so in the next session we will talk about describing motion on a graph. Thank you.